Hi. So today let's talk about the perfect recall. Okay. So normally perfect recall would be a very complicated concept, and normally we in the most of the games we don't assume the agents or the players they have any imperfect recall. Okay. So normally we say that the players would have just have the perfect recall. Okay. So perfect recall refers to something that each player in a game or in a extensive form game, the players they do not forget what they did before. Okay, with the perfect recall. Okay, so if there's some imperfect recall, then players they might forget what they did for the actions previously. Okay, so let's formally define this concept. Perfect recall. Okay, so for each player, I, and for a history, H, okay, such that the player function given some history H is player I. Okay, so now we define some function xi given some history H. This will be a long sequence where we put all those information sets for this player I. So those would be just the, although we have the subscripts from I up to K, but all those capital I's are just the information sets for player I. Okay. And we have information set I1 and then the action from player I after that, right? So this would be action A1 and I2, A2, so on and so forth. And up to IK minus 1, AK minus 1, and the final element would be IK. Okay, good. So here, those are I1, I2, up to IK minus 1, IK. So those are the information sets, okay, that player I met or encountered in history H, and those A's are the action that player I takes. Okay, A1 up to AK minus 1 are the actions that I place. Okay, good. So this is the definition for this function xi. So we'll use that to help us to define the concept of this perfect recall. Okay, so let's have this definition of the perfect recall. So let's say in an extensive game, so extensive form game has perfect recall if for each player I, we have something on this function x. What we have is that xi given some history h, it must equal function xi given some other history h. And the very important part in this definition is that whenever h and h prime are in the same information set. Okay, so this would be a very important condition for this definition, right? Same information set of player I. Okay, let's change the color, and this is actually the most important part, right? Okay, so intuitively, so later we'll give some examples of this definition. Okay, so intuitively, what does this mean? It gives us some standard to distinguish whether this game has perfect recall or not, right? So if let's say if they different history in the same information set, if they're at the same level or in the same same stage, then they should give exactly the same information set and actions in the history, right? But which is given by this xi function. However, if some player they forgot about what they did before, then there might be some information set connecting the past and the current or the future, right? So the information sets, the dotted lines, might just might link the different time stages. So in this case, if we input those different histories in the same information set, so they will come from different history. They'll come from different time stages. So that this xi function will output those different things, right? Including different i's and different a's, right? Okay, so that would be the basic intuition behind this definition. So now let's move on and discuss some examples that we might have shown previously, and also some new examples, okay, to help us to understand this definition. Okay, so let's do that. Example 1. So let's use this old example from last time. So this is nature moves first. This should be player 1, okay? Player 1 moves first, and then player 1 moves again here, okay? So this is L or R, okay? And after playing L, then player 1 moves again, but player 1 actually forgets about if this if player 1 themselves has played or not previously, okay? And this would be L or R, okay? And with some payoffs. So, and we can just move this one to here, okay? So player 1 gets to move twice. So there's only one player. So a very straightforward example of this game would be someone is driving on a highway, and there is a main road or a main way on this highway, and there are many exits. Okay, let's say in a very dark night, the driver cannot directly see the road signs of which exit he should drive out of this highway, right? So this is essentially talking about this game, and since the driver cannot observe those road signs, so the driver simply forgets about all those exits that he met before, right? So he doesn't know if the next exit will be the one he's heading home, right? Okay, so this will be a story for this game. So let's write down the x functions and compare those if they have the same value. Okay, so first here would be given the input, given the history as empty set, right, in the beginning of the game. So when player 1 moves first for the first time, so this would be just the information set itself, and this will be the empty set and L, right? Okay, good. Okay, and then after playing L, then this x function gives something more, right? So there will be two information sets and one action L, right? So empty and L, this will be the first information set when this game was in the beginning, right? And then some action L following that. And then when this game reaches this node after playing L, then the information set is still empty and L, right? Player 1 still cannot distinguish that. Okay, so here, and we could immediately observe that x1 given empty is not x1 given L. Okay, so this is a straightforward example. Now let's take another example here. okay, which were also from the textbook. So, okay, let's suppose nature moves first, choosing either L or R, and then player one moves later, choosing little r, little L or little R. Same here. Okay, with those at the terminal nodes, but with those the game continues. Here we have a information set for player one. Okay, so player one moves again, but here player one doesn't know whether the game is here or there. Okay, so let's see if player one, if this game has perfect recall or not. Okay, so let's verify that for player one, given L and R, given this history, so we are comparing the history LR and RL, right? So given LR as the history, then this X function gives us first this L, right? Because L would be the so after this would be the information set, right? So the action that player one gets to choose is little r, and after choosing little r, then the information set becomes, for player one, becomes LR and RL, right? So player one cannot distinguish between those two. Okay, so that would be X1 LR, right? So how about X1 big R little l? So similarly, we have capital R here, right? And after this history, after that information set, then player one plays L, and after playing L, then player one cannot tell from LR and RL, right? Again. Okay, so, and obviously those two are not the same. Okay, so player one doesn't have the perfect recall in this game. Okay, and as the last example, which is simpler than previous one. Okay, so let's say player one moves first and player one moves second again. So here could choose LR, and then player one could choose a little L or little R again. Okay, but here there's the information set for player one. So after choosing big L or big R, then player one immediately forgets about what they chose before, right? And that's obviously an imperfect recall, right? So let's verify that. So X1, given the history H, so the first, okay, bracket. So the first information set will be empty, and after action L, then this becomes information set becomes L and R, right? Cannot distinguish between L and R. Okay, good. So how about X1R? So similarly, first empty set, and after playing R, and then cannot tell from L and R, right? So those two are not the same. So there's no perfect recall in this game, right? So those would be the examples of imperfect recall in the extensive form games. But normally we'll mainly concentrate on the games with perfect recall, okay? But imperfect recall would still be a very important direction of the research in those kind of pretty sophisticated or complicated games, okay? So those will be also very interesting. Okay, good.